the distribution of the sample proportion. Our objective: describe the sampling distribution of a sample proportion, the proportion of individuals in a sample who have a specified characteristic. Okay, we'll remind ourselves what we know. We know that the sampling distribution of the sample mean, X bar, is described by its shape, center, and spread. When we're dealing with the sampling distribution of the sample proportion, we're dealing with the proportion of individuals who have a specific characteristic. So, suppose we want to determine the population proportion, which we'll use the letter P. The Greek letter for P is pi, but of course that gets confusing with with the mathematical number pi. So we go for, in this case, for the population proportion, we're using the letter P. So we're kind of breaking rank a little bit using Greek symbols. Suppose we want to determine the population proportion P of all adult Americans who plan to work on summer vacation. If we asked all adult Americans, then P is equal to those who said yes divided by the total number of adult Americans. However, as we saw with the mean, all right, it's next to impossible to do this, to ask all adult Americans. So we're going to estimate the population proportion P using a random sample. All right, let's put that together in this box here. Sample proportion. Suppose a random sample of size n is obtained from a population in which each individual either does or does not have a certain characteristic. The sample proportion, which we denote as P hat, okay, because we're using the letter P for the population parameter, we're using P hat for the statistic, okay, and it's given by the number of individuals in the sample with the specified characteristic, okay, divided by the number of individuals in the sample. Okay, and we have here, divided by the sample size, excuse me. P hat, the sample proportion, is X, which is the number of individuals in the sample with the characteristic, divided by the size of the sample. The sample proportion P hat is a statistic that estimates the population proportion P, which is a parameter. All right, let's do an example or two of that as I get myself organized. Pardon me for just a moment. Here we go. The Harris Poll conducted a random survey of 1,200 adult Americans who vacation during the summer and asked whether the individuals plan to work while on summer vacation. Of those surveyed, 522 said they do plan to work while on vacation. Find the sample proportion of individuals surveyed who plan to work while on summer vacation. Okay, the sample proportion is P hat. Okay, the sample proportion is P hat, and it's equal to the number who have the characteristic, in this case, the 522 that said they plan to work, divided by the sample size M. Here's the sample, N. Here's the sample size. So we have 522 divided by the sample size of 1,200, and we come up with 0.46, and that is our sample proportion. Okay, as we discussed with the sample mean in a previous lecture, as we know, a second random survey of 1,200 adult Americans is going to have a different estimate. Okay, there's no way we're going to sample 1,200 adult Americans. Whoops, you can't see that. Chances are very small that we're going to estimate 1,200. We're going to do another sample of 1,200 adult Americans, and we're going to get exactly 522 that say they plan to work. So every time we do this, 1,200 Americans, how many plan to work? Another sample of 1,200 Americans, how many plan to work? We're going to get a different number up here. Not every time, but these numbers are going to change. Okay, so that becomes A. Okay, because we're going to get different. As with sample means, it's going to vary from sample to sample, and thus P hat becomes a random variable with its own probability distribution. And again, as with sample means, this distribution has shape, center, and spread. As the size of the sample increases, the shape of the distribution of the sample proportion this time is approximately normal. We saw that with sample means. The mean of the distribution of the sample proportion equals the population proportion. The spread, as the sample size increases, the standard deviation of the distribution of the sample proportion decreases, and that took place with the mean as well. All right, so let's recap. Let's put that together. And what do we know? Okay, so the sampling distribution of P hat. Let's remind ourselves this is P hat. The sample proportion is called P hat. For a simple random sample of size n with a population proportion P, the shape of the sampling distribution of P is going to be approximately normal, provided n times P times 1 minus P is greater than or equal to 10, and provided the sample size is no more than 5% of the population size. Mathematically, the sample size is indicated with a lowercase n is less than or equal to 5% times the population size. This first one is really the key one. Your sample size is almost always going to be less than 5% of your population size. That's there. It really won't come into play a whole lot because we're talking about a large population and talking about a fairly small sample, usually, which is well less than 5%. Okay, as with sample means, the mean of the sample distribution of P hat is denoted by mu sub P hat, subscript P hat, same. And the mu subscript P hat is equal to P. The standard deviation requires this formula. The standard deviation of the sample distribution of P hat is denoted sigma sub P hat, and that's equal to the square root of P times 1 minus P over n, the sample size. Okay, let's take a look. We'll do one of these. I think that'll help make sense. As a very similar feeling to what we just did regarding sample means. Similar feeling to sample means. Suppose the proportion of Americans who believe that the state of moral values in the U.S. is getting worse is 0.76. So the majority of Americans, again, as a percent, this is 76%. The majority of Americans say the state of moral values is getting worse. Mathematically, P, okay, is 0.76. Okay, we obtain a random sample of 60 Americans and determine which believe that the state of moral values is getting worse. Describe the sampling distribution of the sample proportion for Americans with this belief. Okay, well, we can't describe it until we come up with, if we have a normal, we can't say it's normal. Okay, we can't say it's normal until we remember, we want to be normal. We can't say it's normal until these two conditions are met, condition 1, condition 2. Okay, so let's take a look. Condition 1, NP times 1 minus P must be greater than or equal to 10. Well, N is 60. N times P is 0.76. 1 minus P is 1 minus 0.76. I put that into a calculator. and out comes 10.944. Well, that is definitely greater than or equal to 10. So that's my first test of normality. It passed the first test of normality. Second test is our sample size less than or equal to 5% of our population size? Well, think about it. Our population is massive. 60 people is way less than 5% of our population, so we'll write that down. So that's test number 1. And test number 2, 60 Americans is far less than 5% of the U.S. population. Okay, so it's normal. Describe the sampling distribution of the sample proportion. Now I can do it. The sampling distribution of the sample proportion, which is p hat, is approximately normal. Because we met the 2 criteria, it's approximately normal. That's a good thing. We like normal. Okay, normal with the mu p hat equal to 0.76, which is right here, and sigma p hat equal to the square root, the standard deviation of p hat equal to the square root of p minus p times 1 minus p over n, which equals the square root of 0.76 times 1 minus 0.76 over 60, which comes out to 0.055 to 3 decimal places. So we did a check. We came up with normality because these 2 conditions were met, and it's normal with the mean of the sampling distribution of p hat is 0.76, and the standard deviation of the sample distribution of p hat is 0.055.